Hello everyone. Wireshark is a free and open source packet analyzer. It is used for network troubleshooting, analysis, software and communications protocol development, and educational purposes. Now originally it was named Ethereal. The project renamed again to Wireshark, so its original name is Ethereal. But due to trademark issues, it is renamed to Wireshark. That was in May 2006. Now, the Wireshark is a cross-platform. What is cross-platform? Cross-platform that the program or this utility, which is the Wireshark, can run to many platforms like Unix, like Mac, like Windows, etc. Also, the Wireshark is written in C++ language. Don't forget that it is free and open source. You can find the source code to this one. Okay, now Wireshark has won several industry awards like eWeek, InfoWorld, PC Magazine. So also it is a top-rated packet sniffer in the insecure.org network security tools survey and was the SourceForge project of the month in August 2010. So what is packet sniffer? The packet is a concept we name every bits or every communications or every files or every things on the internet, we call it a packet. So it is a packet sniffer. So we can see the traffic or the internet traffic. Now Wireshark has many features. So the data can be captured. The data is the packet here, okay, from the wire, which means from a live network connection, or read from a file of already captured packet from a live network. Just while you are running your Wireshark and you are capturing right now, just open your browser, type google.com, press enter, or type udemy.com, press enter. Now you will see all the traffic and all of this will be captured. Or you can save what you are capturing right now, save it to a file, so if you want to check it later. Okay? Now live data can be read from a different types of networks. So Ethernet, which is the original one, I mean the lines or the DSL fiber and so on. This is the RJ45 jack and the plug. IEEE 802.11, which is the Wi-Fi, PPP and loopback for the local host. Captured network data can be browsed via a GUI, which is the graphical user interface with the screen, okay, or via the terminal command line version of the utility, which is named TShark. It is much recommended to use the GUI, of course, because it is much easier and you can save time. But command line has many uses, so we will not handle those details. Captured files can be programmatically edited or converted via a command line switches to the edit cap program. What we captured, we can edit what we captured. This is very important for security issues and so on. All of this will be discussed, so don't worry. Data display can be refined using a display filter. Now this is important. We will use a filter in Wireshark. There is a filter and many filters or syntax we will type and we will write in this program. So it is very important thing to find the IP address, what the protocol, what is the port number, from where the packet we have, or where are going the traffic. So this is very important, and many things. All these details will be discussed in this course, so don't worry and stand still. Now the plugins can be created for adding new protocols to the Wireshark. So there's protocols like TCP and UDP. It is very important. They are very important, but if they are protocols that not used, so we can add it, or not used, or used rarely, we can add it later to the. So it is, as we mentioned, it is an open source. Now this is important. VoIP, which is the voice over internet protocol. Now the VoIP is the voice over the internet protocol, which is the voice. You record the voice and send it to someone. This will be captured and can be detected. And if we encode this media flow, we can play it back again. This is very dangerous thing. So as we mentioned, this course for security and anyone who want to know what's going on. So also the raw USB traffic can be captured if you are copying files and pasting and so on. Wireless connections can be also filtered as long as they are traversed due to the monitored one. Various settings, timers, filters can be set to provide the facility of filtering the output of the captured packets. Okay, now let's start with downloading the Wireshark and set up the environment. Now open Google, type Wireshark, as simple as that. Yes, open Wireshark here, or the download immediately. This is the download. Now download what version you want, either the latest version 2.6 or the old stable releases, which is the 2.47, or here with the documentation, and here is the development release. But it is recommended to download the latest, of course. Now download either 64 or 32. Okay, or the source code. This is macOS and later Intel 64, and this is the portable apps. But if you want this or this, if you are a Windows user, and this course for Windows, it is the same. Just download it on any platform you want. Now I will download 64. Okay, I've downloaded it already, so open it, double click on it, yes. Now click next, I agree. Now this is the Wireshark. As you see, this is the classic user interface. Just make sure it is clicked. Let the default settings as is. Okay. Now click next. This is the some options. Create this Wireshark desktop here, or legacy desktop if you want for the older versions. This is the associate trace file extensions to Wireshark. Any file extensions that support the Wireshark then will be associate to this program, which is the Wireshark. Associate means that the program will be opened using this application, which is the Wireshark. Now click next. Yes, as you see here, this is program files, which is the 64. But if it is a 32, then it will be 86x. Okay. Install WinPCAP. This is to capture a live network data. Install the USB PCAP to capture the traffic used on the USB. Yes, download it. This is the link if you want to know more. Notice. Just install it like this. Okay. Now it will take a lot of time, from 1 minute or 2 minutes, depends on your system. Okay, and so on. Now it will be there's another window to install the USB PCAP, the WinPCAP. Just click next, yes install, and use the default settings. Okay, like this. Now WinPCAP. Okay, now click next, I agree. Automatically yes, install. Okay, just wait a second. Yes, USB PCAP driver is depending, and your reboot is required. Of course, you need to restart your computer after the download or the installation, is complete. Okay, now let's start with download and installing Wireshark in Unix. Now in Unix or Linux, let's say, in Kali, for example, this distribution, this is for security and hacking, for ethical or non-ethical hacking, of course. Now the Wireshark is already installed, but you can update it if you want. But in Ubuntu, it is not installed by default, so you have to install it, and so you have to download it and install it. Okay, Now let's see these instructions. Now the first thing, copy, oh sorry, I will copy, you have to write it yourself, just like this, sudo add dash apt dash repository p space here pppa colon wireshark dash diff dash slash stable. Just type it. Type the password if you have password for that. Yes, press enter. Just try as it give you like this. Now we have to update our system, the repository and the libraries we have here. Okay. After it is done, this will sudo apt-get install Wireshark. Okay. Sorry, my internet connection is slow somehow. It will take a lot of time. Yes. Almost done. Almost there. Almost there. Oh yeah. Come on. 13 seconds. Okay. Then we have sudo apt-get install Wireshark to install it. Then sudo Wireshark to start the utility, which is the Wireshark. Okay. Now, as you see, it will take a lot of time because it will update the whole library to the whole system. Yes. Now sudo apt-get install Wireshark. Yes, as you see, 83 megabyte. Yes. Okay. Now wait for it to install. Now look at again at the instructions. Now if you face any problems or any something misunderstanding or errors, just let me know or ask me the question as you want. Now after you install apt-get install Wireshark, but it will take a lot, as you see, 26 minutes. It will take a lot of time, so I will skip that. So after it is installed, okay, now just sudo Wireshark. Now as you see, the Wireshark, if it is run as a sudo, which is the super user mode, this will be a security concern, and it will give you a warning, okay, or error, but it will run no problem. It will run smoothly, no problem. But as a security mind, we have to consider we cannot run the Wireshark in sudo mode. So what we have to do now, Wireshark, when we download Wireshark, the Wireshark itself create a group into the system, okay, a group to add users to it. Now what we have to do, we have to add your user to the system, to the group, which is the Wireshark. Forget that. If you get an error, couldn't run this and in child process, then you go to the terminal and sudo type this, okay, say yes, this adds a Wireshark group. Okay, this is what I'm talking about. This will add a Wireshark group if there's an error, okay, if there is an error. If there is not, no, don't. Now, but if you have the problem, just add this. When the download and everything is done, just add this, sudo add user, as you see here, add user. This is to add the user. This is the variable, system variable, environment variable. This will give you the current user, okay, and add user. This user, it is already created, or it's, yes, this is your user, okay, and add it to this group, which is the Wireshark. Okay, this is the way to create a user and add it to a specific or to exist group. Okay, sudo add user, this user with capital, to Wireshark. Okay, now if I type echo user, echo, this is a command to print on the screen. So this is a variable, so I want to print what is this variable. As you see, this mmz, which is the user I am using right now. If I type this command, who am I? Yes, it is mmz. So the user right now is mmz. Who am I is mmz. So this is our user. Our user, it's already created, of course, and added to Wireshark, which is the group. Let's see this. It will take a look. So now, how Wireshark works. Now this image is the simplest how Wireshark works. Now look at this. This is our computer here, okay, with this IP address. This is an example, of course. It may different in you, and we are using Windows machine, as you see. And this is the network. This is where Wireshark sniff the packets, as we mentioned before. The packet, it is a data on the internet. Data on the internet, we call it packet. Okay. Of course, this is the simplest way to define what is packet. You can just type packet and see more definition or advanced definition. Now this is the network here. Now, and this is the server we are trying to connect to. Now, just the simplest way. In your computer or in our computer, open your browser, Firefox, Google Chrome, Opera, Edge, Internet Explorer, and so on. Open your browser, type google.com, press enter. Of course, while you are running Wireshark. Now you will see the packets coming and sending and receiving, sending from our computer and receiving from the google.com. Okay, of course there will be levels, DNS, depends on your location, what the ISP, internet service provider, I mean, the routers, the edge routers, core routers, or the route you are trying, what the DNS you are using, and so on. It may different from computer to computer or from networks to networks. Okay, now for more advanced how Wireshark works, look at this. This image is original from the Wireshark website itself. Okay, I've downloaded from the documentation. Now this is our computer here, as you see, and this is the network. This is the bus or the wire using the Ethernet. We are connecting to the network. To the network that connected to google.com in the previous example. Now this is Wireshark. As you see, this gray box here or rectangle, okay, this is the program of Wireshark. Now as you see, has many features. There's a GUI, which is the graphical user interface that we are trying to. Now this is the core, which is the source code, the main program, okay, with many features like protocol tree, dissector plugins, as we mentioned before in the first section lecture, sorry, that there's a plugins if you want to add a new protocol, if you add to new features, and so on. This is the display filters. As we mentioned, this is the most important in this course, to filter the packets, specific IP address, specific port number, specific protocol, and so on. As you see, this is the utilities. Also with utilities, I mean here and here. Okay, now we will capture, as you see, from the core, we will capture packets and we will wiretap. Wiretap, we can modify what we are capturing and save it to a new file. The default file is .cap. If you want to save it to another extension, if you want to change the file, and so on. This is the wiretap here. Now we will, of course, the wiretap here will save what we captured and the modification we have changing or we have changed to the hard disk, as you see here. And the capture also will dump cap, capture engine. Now what is dump cap? Dump cap, what we capture, the raw packet that we captured. Okay, we capture it and we saved it into the hard disk. As you see, this is the WinPcap. WinPcap, firstly, before we, if you remember, when we installed the Wireshark, there was a box here and check to install WinPcap. This is to capture the Windows or the packet using Windows. Okay, or to capturing the packets in Windows. Okay, as you see, this is the with utility like or with more feature like a capture filters, and this is the network and so on. Of course, okay. Of course, if you have any question, just let me know. Now let's start with Wireshark. This is the main graphical user interface to Wireshark. As you see, this is the file here. Open. If you have saved like this, saved what you captured, you can open it again later. This is file set, export, packet, decision. If you want to export as a C array, as a CSV, plain text, and so on, JSON, as you see, export packets, bytes, export PDUs file, export per object. Okay, now this edit, copy the file. Of course, all of this is not available. Of course, we are not capturing anything, but this is the graphical user interface. Now this is view toolbar to see the status bar, wireless toolbar, and so on. Of course. Now all the details here, or the boring details here, will not be discussed because it is easy. Of course, if you want to full screen, that's for sure. It is full screen. Time display format, if you want to. This is easy. This is not what the course is. Okay. Just I want you to know that there is something like this. If you want to change the color of the internal and so on. Go, if you want to go to specific packets. This is somehow kind of filtering, but this is not the filter we are talking about. Capture, if you want start, stop, restart, the capture filter, refresh interfaces. All of this will be discussed right now after we complete this. Now this is analyze, if you want display filters for specific packets, apply filter for a specific or such thing. Okay, now this is the SCTP, the old version of TCP. This is the previous protocol. This was used before TCP, but after after implementation of TCP, this is old right now, old and not used. Rarely, it's used rarely, or maybe some servers use this protocol. Okay, now this is the statistics if you want to know anything. Okay, now all of these, as you see, will be discussed in the right time. Okay, so just stand still and focus with me. Okay, this is the telephony. This is, as you see, VoIP calls, ANSI, GSM. Okay, if you want to know specific packet, SCTP, as you see, SIP. Okay, wireless, there's Bluetooth, WAN, WLAN, traffic tools. If you want LUA, Lua. Okay, this is here. If you want any help, if you want. Okay, now how to start capture our first packets. Now choose the specific, or sorry, choose this, as you see, capture or use. You have to choose your interface. Okay, what is the meaning of interface? Interface, it is let's say it's the device or the NIC, which is the network interface card that you are using. Either you are trying, or you are capturing using Ethernet, which is the wired. Okay, or you are using Wi-Fi 802.11, which is the Wi-Fi. Okay, wireless. But I am using right now the wired, as you see here. I am using wired network 2. Okay, now I have two devices. How to know which one? Now I don't know why. Let's open it again. As you see, just wait a minute here. Okay, maybe it's not responding, but it doesn't matter. And there must be, okay, signals. Right now there's no signal. As you see, that is the signal. Now Ethernet 4 has no signal, which means that this is not IP. This is not the working interface right now. But this is the main, or this is what I'm capturing. Why I have two interface? Maybe the device or in the computer. I've downloaded a virtual machine or VMware. Okay, and the VMware install a new interface to the system, to Windows 10. Okay, so that's why I have two interfaces, the main interface, and this is the virtual main interface. And of course, why why there is no signal here, because I am not open, or I'm not open, as you see, no VMware. Okay, so that's why no signal here. But as you see here as a signal, this is the main, so I will choose it. As you see, if I choose it here, as you see, you will see a whole thing. Actually, but why this? Okay, now if I try here and I type Bing google.com, okay, as I am Bing right now. As you see, all the buckets will be here. As you see, now I want, this is the start. I will stop it right now. Okay, now the Bing, of course, it will send ICMP packets, ICMP Internet Control Message Protocol, echo request, okay, echo request, echo reply. As you see here, all of these, just forget all of these, okay, because this is before I tried to Bing. Now this ICMP, this is the Bing request. What is the source IP address here? Now this is the number of packet. As you see, I have 23 packets captured. This is the number. This is the time that when we start the capturing. After I start the capture, 13 seconds, then we capture this. Okay, now this is the source IP address. This is my IP address. This is the destination. Okay, and so on. So let's say at the time, sorry, the number, I mean, sorry, yeah. As you see, this is the source IP address, this is the destination. As you see, this is the request type, which means that it's from my computer. I send to this server, which is google.com. This is the IP address of google.com. So the source IP address is mine, and the destination is google.com. So this means what? That this is coming from my computer to me, sending from my computer to google.com. This is the request. Now the reply comes from google.com. As you see, this is the same IP address as here, yeah, and going to sorry, let's, if you don't see, yeah, let's yeah, this is better. Yes, this is the source IP address, which is from Google, and the destination IP address is my IP address. So as you see, no problem at all. Request, reply, and so on. This is again request, another request from my computer. This is source IP address. Source IP address, or the source IP address, is where the bucket come from. The destination IP address is where the bucket going. So when the bucket coming from my computer, or sorry, coming from this IP address, which is my computer, and going to google.com, this means that coming from my computer and going to google.com, and from name, it is a request. Okay, and this is reply. Okay, reply, as you see, the source IP address coming from google.com, going to my computer. Okay, of course it may different on you, this may change, okay, and so on. Okay, now all the details of all these protocols and how to find a specific IP address, specific protocol, specific port number, a specific flag on a specific protocol, all of these will be discussed, okay, in details. So don't worry. Okay, now the main course here will be in this field. As you see, this is the display filter. This is the filter we will try, and we will use all the techniques, and I will provide you with a sheet with all the details, or all the filters will be in that sheet. Okay, all the most important, at least the most important filters will be in that sheet. So stand still with me and focus. Now, how to capture packets with a specific IP address, source, destination, or source and destination. Now the first thing, make sure you are running Wireshark. Yeah, I'm running right now, I'm capturing. Now open your browser, type google.com. This is what we will to practice today in this lecture. Yeah, you can stop it here. As you see, I have captured 800 packets just for 30 or less than 30 seconds. Okay. Now it is more sense. It is sense to use this filter field. Okay, to filter the packets. Of course, not to look at these packets one by one. Now, what if I captured for 1 hour or 2 hours, 3, 10 hours? This will be reached to huge number. Of course, you cannot say yeah this, no, not this, yeah this packet. Of course, huge number. May 1 million or 2 million and so on. So inside the filter field, you will put this command. But the first thing, you have to know what is the IP address of google.com. Of course, you can use three-way: Bing utility, google.com. Yeah, this is the IP address. Yeah, I know Bing utility to send ICMP packet and send and receive echo request, echo reply, and so on, with many, of course, many types, but this is the most popular. Yeah, but also, and to check for connectivity, it is up or down, but also has a resolver. Bing has a resolver to resolve the IP address of the specific domain name. Okay, now the second way is to ns lookup google.com, but it is old somehow and not recommended. As you see, one answer here, and this is the MAC address with, yeah. And the third way is to use the dig utility. So now the dig ib, dig web interface, or any website you want, but it is recommended to use this site because it has many features. Sorry about that. Yeah, with many features and saying many things. So type google.com here. You can use all or resolver or anything, dig. Now as you see, the result is huge. All the IP address. If I want the resolver only, then I will get this. Okay. Now if I put this now, okay. Now this is the work. I got what is the IP address. This is the IP address of Google. Yeah, yeah. Okay. IB. This is the command. ib.addr space equal the IP address. Press enter. No. Why? No. Yeah. As you see, the IP address is different. Okay, so put the IP, make sure it is the correct IP address. So it is recommended to use the Bing utility. Okay, no result at all. Sorry, sometimes I didn't capture with the right. I will restart it again. Google.com. Yeah. Okay, stop it. Now I Bing google.com. As you see, the IP address is made different. Okay, in specific, what is the type, or sorry, what is the services of your DNS, or what is the DNS IP address you are using, what your ISP what using, where is your location, what is the restriction on your location, and so on. So make sure you know what is the correct IP address of the website you are capture. You want to analyze the traffic you are capturing from. Okay, so ib.addr from address equal the IP address. As you see, no problem at all. I find this is the correct one. Now as you see, the source and destination. Now this is the same. As you see, the protocol is TCP. TCP, three-way handshaking. SYN, ACK, ACK. As you see, the source is from my computer, and the here from Google to my computer. As you see, source, destination, coming from my computer to google.com, which is the same, of course, coming from google.com to my computer, SYN ACK. And this is the ACK, which is coming from my computer to google.com, and so on with you, as you see. Now what if I don't want the source and destination, I just want the source. So instead of ADDR, type SRC. Okay, now as you see, the source IP address is like my here is the google.com IP address. Okay, this is the source, as you see. Now the other thing is the destination, DST. So simple. Okay, the destination IP address, as you see, this is the SYN and this is the ACK. The SYN ACK is removed because why? Why is it removed? It is coming from google.com, which is the source IP address is google.com, not the destination. Okay, I'm going to my code. Okay, this is there. So 3 commands: ib.addr, ib.src, ib.dst, destination. Okay, so simple. Or how to find the IP address? Bing, the google.com, or ns lookup, but it is not recommended, or dig. But dig, this is not installed in Windows by default. I'm using Windows 10. You can find it online. Okay, dig interface, just type dig ib, dig interface, or dig web interface, or any website you want. Okay, now the other thing here, before I give you the quiz now, make sure you choose the right IP address. As you see, company or website like google.com has a huge number of servers and so many IP addresses and so many DNSs. So make sure you choose the right and it may different. Why? Because it depends on your location, in your ISP, internet service provider, or the restriction in your location, and so on, with many policies, let's say. So just before this course, if you don't know what is DNS or how DNS work, just make sure to open google.com, type how DNS work, and know how DNS works. Okay, before you continue, pause the video right now and do it. Okay, now with the quiz. Okay, now this quiz will be on YouTube, okay, or any website, it doesn't matter. Okay, I want you to find all the traffic that's been captured from YouTube. Okay, now you can pause the video or you can continue. Okay, let's continue. Now the first thing, remove this, press enter. Now start capturing. Now I am capturing right now all the traffic through this interface. Open youtube.com. Okay, yeah, as you see, this is open. Now you can either stop it or let it as be. Stop it. Now type ib.addr equal. This will be, I put the youtube.com. This is the IP address. So I will type it here. Yes, as you see, this is the SYN ACK. As you see, this is all that. I want the source IP address src, ib.src. I want the destination ib.dst. And you see why this is red, because it is reset. Reset means that in TCP that the connection is broken, or the connection is closed, and so I mean many concepts. Okay, now how to find port number with a specific protocol. Okay, now the first thing, capture the packet. Okay, now we are capturing packet on this interface. Open your browser, open any website you want, google.com for example. Okay, now as you see, opening, stop it, or you can let it be. Now inside the filter, type the name of protocol you want. So I want to use TCP, for example, transmission control protocol. Okay, as you see, all the result will be displayed as a TCP from 370 to 306. Okay, now if I want TCP, if I want specific port number, dot port equal. For example, now I open Google. And don't forget, Google use HTTPS, which is secure. So the HTTPS port number is 5443. Okay, so port number, just if you don't know, HTTPS port number or port is like this, as you see, 443. So equal 443. Yes, as you see, either source or destination. As you see, this is the destination, this is the source, this is the destination, this is some data, this is the source, this is the and so on. If you double click on this, you will see all the values you want. All of these values are extracted from this hexadecimal values or hexdump values, as we mentioned before. Okay, now what if I want only the source port number? So instead of port here, just type src port. src port here, it doesn't matter if you put space or not here, or some versions it is mandatory to put space here. Okay, TCP.source port, as you see, this is only the source port number, must be like this. So this means, this filters mean, or this command, TCP.source port number must be like this. So as you see, must like this, and this, and this, and this, and so on. If I want the destination, you will put DST port number. So simple, so easy. Okay, as you see, TCP.destination port equal, as you see. Now what if I want to change the protocol to UDP? It is the same, UDP. Instead of TCP, just type UDP. Now of course, UDP will not use such a thing. UDP will not use the destination or source port number with this number 443. It is for HTTPS, which is using TCP, HTTP or HTTPS using TCP. That's for sure. That's known. Now if I put UDP, all of the data almost would be DNS. Of course, DNS. Of course, now DNS, domain name server, using UDP. Why? Because it is much faster, and UDP is effort guarantee, or guarantee, no guarantee, which means no effort, no guarantee, no congestion flow, no error flow. If you don't know the difference, just open Google UDP versus TCP to know the difference. Now if I want to specific port number port equal now DNS use DNS port number use 53 number equal 53. As you see, this is the IP address, or the port number, sorry, of UDP. If I want to source SRC port number, DST port number for UDP, all the services I'm using UDP like DNS will be displayed, but that must be as a destination. Okay. Or if I want to put another protocols like ICMP, Internet Control Message Protocol, yes, as you see, there is only one from 370 packets. There's only one cap displayed. Okay, delete this. Now what we have learned today, how to find port number on a specific protocol: TCP, UDP, ICMP, or any other protocol you have, and the Wireshark must recognize it in its files, or you can add it as we mentioned before using the plugins. Now TCP.port equal anything. In this, our example is like this, which is the HTTPS, okay, or SRC port number, or DST port number, okay, port number. Or you can use the UDP, of course nothing. UDP, there's many as we mentioned, that many services using UDP, like the DNS service, which is 53. How to know it? Just open Google, type DNS port or HTTP port, or not ICMP. ICMP, it is not a network layer protocol. It is less than network layer. But the UDP and the TCP is a transport layer protocol, so has port numbers. Okay. Now I will give you this quiz. Now it will be easy. Just revision. Find on YouTube. Okay, on YouTube again .com. Find the port number. Okay, either the port number for HTTPS. Okay, no problem. And then find the port number, either destination or source, it doesn't matter, for HTTPS. You can pause the video or we can continue. Let's continue. Now the first thing, make sure you are connecting or you are capturing. This is YouTube. We have opened it. Yes. As you see, 1004 packets, 400 packets. Stop it, or you can let it be. Now, HTTPS. HTTPS means TCP connection. So TCP.port equal 443. As you see, all the packets has been captured. As you see, from 1500 to 1400. So 6% is deleted from the result, or not displayed. Okay, you can SRC if you want this. As you see, 900, or DST for destination. Sorry, destination, and so, and or not in Wireshark. Now, what if I want to display a specific IP address, for example, with a specific port number? How to do that? Using and or not. Let's start. Select your interface. Now we are capturing right now. Open google.com or anything. Okay. Yes. Now stop it or let it be. Now as you see, all the packets has been captured here. As you see, 543 packets here. As you see here, displayed 100%, which is the same. Now I want my IP address. How to know my IP address? Using ipconfig. I mean the local IP address. The private IP address. This is the gateway I'm using right now here, and this is my IP address. Okay. Now the first thing, as we learned from the previous lectures, ip.adder equal this. Now I want to use and, so simple. And TCP, because it is HTTP, don't forget that, .port equal 5443. Why 443? Because it is HTTPS secure socket layer. Yes, as you see that any source or destination number, or its destination IP address, with this IP address that I bought, because I bought here adder, not source or destination. Okay, and here is both, either source or destination. Okay, so this means that anything will be here. As you see, the source port number is here, and must, and you know the logical and how operates. The two things must be true to be a true, or the two things must be, or one of them must be false to be false. Okay, so this packet, for example, has IP address is like this is my IP address, the source or destination, because I put here adder. And here, as you see, either the source port number or the destination port number must be 443, so it is displayed, and so on. Okay. Now, how to use or? So simple. It is the same. Instead of and here, just put or. Okay. Now, or you know how to operate, or anyone to be true, there anyone will, if anyone is true, then the result will be true, or if the two false, then the result will be false. Okay, now as you see here, this is DNS. Why DNS is because it is OR. Now as you see, the port number here is not 443, it is DNS, which means 53. Okay. But the source or the IP address, as you see here, is 192.168.8.100 and so on. Okay. Now this is OR. Now NOT is somehow different. Now what if I want to display everything? As you see here, I don't want my IP address to be displayed. Okay. Or for example, I opened here Google. Okay, I want to open YouTube here. Okay, sorry, I have to capture again. Remove that, remove this. Google.com, YouTube.com. Okay, now YouTube has different IP address than Google. So let's Google just to stop it. Okay, Google.com, to know what is Google IP address here. Yes, open here. Sorry. Google and Bing for YouTube. Yeah, like this. This is for YouTube. Okay, YouTube. And this is Google. Now remove that. I want to display ib.addr equal Google IP address. Okay, which is like this. Now as you see, all the packets here for google.com. Okay, now I want to display YouTube, so I will put the IP address of YouTube. All you see, as you see, all the packet here is for YouTube. Okay, now what is the usage of NOT? Now NOT is I want to display all the packets that Wireshark has been captured, which is 1943 or 1943. Okay, and I want to display all the packets, but except Google. I want to exclude Google from the result. I don't want Google to be shown. So what to do is put like this. So this will give us the IP address of Google. Okay, but if I put NOT before it, this will give us all the packets. Okay, all the packets, but not all the packets, but not with IP address like this. Okay, so NOT to exclude the result. Okay, NOT to exclude the result, and this is to exclude IP address, as you see from our search. Okay, yeah, thank you for today. TCP in Wireshark. Now the first thing, TCP stands for Transmission Control Protocol. You have to know that, of course. How TCP works, it's like this. You have to know, of course, but quick revision. As you see, this is SYN, the client sent to the server, SYN with sequence X here. Okay, now the server return back or receive what we received, and SYN ACK. The ACK must be X plus 1. I think the sequence will be Y, and the client will send ACK Y plus 1, sequence X plus 1, and then it started to translate data. Okay. Okay. Now TCP has many flags. Okay, like SYN ACK, as we mentioned, ACK reset to reset the connections if the connection is down and so on, or the connections is not established correctly. FIN to stop the connection correctly. Urgent and push. These are two flags. You have to know about them, of course. But as a quick, revision from urgent. If I want to send the data immediately, it is urgent from its name, and this is push. If I don't have to wait for the TCP buffer to be filled, so I put this flag on to push the data or to send the data immediately. Okay, now let's start. The first thing, open this. I will start with google.com because it uses us here, as you see, HTTPS. Stop it if you want, or let it be as it. Now the first thing, I want to see TCP. Press enter. Now all, of course, there will be no, and there will not be another protocol. No, I mean, it may be diff DNS use UDP, so we will use UTCP right now because it's the TCP.flags .sin equal 1. Now all the here will be sin or SYN-ACK, because SYN-ACK has two things, SYN and ACK. Okay, so as you see, SYN, SYN-ACK, SYN-ACK, and so on. Okay, now what if I want to be SYN and SYN-ACK only? Yeah, like this and this and this. So simple. Have to put and either here, either like this, or and. It depends on you, like a programming. Okay, and tcp.flags.ACK equal 1. This means that must be SYN and ACK. So as you see, all the bucket has been displayed, which is 11 here from 305. Yeah, is SYN ACK. Okay. Now this is the SYN and SYN ACK. Now what if I want to make not SYN, FIN? Okay, FIN means we equal ones. FIN means the data is finalized and finished. That is the result. Okay. Now SYN, SYN-ACK, ACK. If I want to ACK, just put ACK here. Okay, tcp.flags.ACK equal 1. Okay. As you see, all the data here is acknowledged. Yeah. Now if I want to fin, as we mentioned before, to finalize the data, now reset. Now if I want to TCP flags reset, as you see, remember that if there's an error here, so if I from the client, if send to the server didn't return back. Okay, so this is not exist. Imagine with me that this is not exist, so there will be no acknowledgement, and if there is a timeout, okay, interval, then the server will send reset. If the client trying to connect, the server will send reset. Okay, so this, as you see, from my computer, which is the .8.100, the destination to google.com, as you see, reset from this port number source, and this is the destination. This from my computer going to Google means that this is reset. Okay, that the connection has been dropped or discovered. Okay, now this is the reset. Okay, SYN, ACK, reset, FIN. Now urgent and push. Urgent from its name, urge equal 1. There's no urgent at all from the buckets I have captured. Is there push? Let's see, BUSH. Yes, there's a lot of push, as you see. And why this will happen? Of course, why is this? Because we don't need to TCP buffer to be filled to send the data. I want to send, for example, let's see this here. As you see, I don't want to let the length be full. As you see, the Windows size for TCP is 63,000, but the length is 69 only. So I just push it to the server. Okay, now this is with the TCP. Okay, now what if I want to connect, for example, to YouTube like this, and I have to run it again. open Google, again open YouTube again, for example, here. Okay, now stop it if you want. As you see, FinX application, stop it. Now I want to know if there is YouTube has been either way. I have two ways, either Bing youtube.com to know what is the IP address, or the three methods that we have learned before. So I have to put ib.adder equal this. This means that this is the YouTube, as you see. And if I want to exclude it, just put not here, and it will be excluded from the result. Or instead of not is shift 1, like this. It is the same as a programming, okay? Shift 1. Or I can use another method. You can't put here YouTube. Sorry, tube. As you see, cannot. But how to do this? You can use TCP contains YouTube. As you see, this is the YouTube. From this is these packets are from YouTube. Okay, these packets are from YouTube. Or TCP contains Google. As you see, these packets from Google. Okay, as you see here, Google, adder, rive.com, and so on. From the buckets, from the row or this hex dump values, the Wireshark recognizes these values. It is coming from google.com or from YouTube. Okay, so what have we learned today? tcb.flags.sin equal 1. This to show up, or equal 0. Okay, this to show us all the sin. Okay, or I can put ACK here, or using sin and ACK, using and tcb.flags.sin equal 1. This is sin ACK only, as you see, sin ACK only. Also fin equal 1, reset equal 1, as you see all the reset packets. Push, as you see, urge for urgent packets. Okay, and TCP contains Facebook, nothing, or YouTube, or google.com, or Google. If I put .com here, also will give us another text. Okay, thank you for that. UDP in Wireshark. Now UDP stands for User Datagram Protocol. It is a best effort protocol. What does best effort? Best effort, it means that no guarantee at all that the data will be received, or the data, it is the original data. So this means the best effort. Now UDP has no congestion control, no flow control, no most of the features in TCP is not on UDP. So why to use UDP? Of course, for its performance, and it is much faster. Then also didn't forget that DNS use UDP in almost every DNS servers use or services use UDP. Okay, now I provide you with an image to simple comparison between TCP and UDP. If you want more detail, just Google. Now the first thing, open your interface. Now I am capturing right now. Open google.com here. Okay, just wait for it. Okay, now as you see, I have connected. Now stop it if you want, or let it be. Now UDP filters here is like TCP. UDP, enter. Yes, this is all the packets that use UDP, as you see. UDP.src or UDP.port before that, .port equal 53, for example. As you see, this is UDP. DNS port number is 53. If I want the source port number, just like TCP, udb.source port number. If I want the destination like this, the udb.destination port number equal 53. Okay, now if I want another thing, which is the checksum, now udb.checksum, as you see here. As you see, if I want to, as you see now, if I want to checksum.bat, that is that. Now, what is checksum? Checksum is a method or mechanism to calculate if the message is correct or not, or if it is the original message that's sent from the server to the another server or to another client. Okay. Now, to know how to calculate checksum, what is checksum, just make sure to Google it and know all of the details. We will not handle all the details like this. Okay. Now, the last thing here is length. Okay. udb.length. Now, if I want to check, now double click on any bucket you want, like this, for example. As you see, all the details is here, captured from hex dump values, that how the packets transfer into the internet or to the wire. Okay. Now, the Wireshark, as we mentioned before, Wireshark will pass all of these details to its values. Okay. Now, if you click here, user datagram protocol, if you click here, double click or press the arrow, yes, you will see the source port number, the destination port number, the length. As you see, the length is 41. Okay, you can see the checksum and verified here, and domain name, query. You can see the flags. You can see what is the type of the query. Here, as you see, the type is NA, class N, and so on. And the response is 15. Okay, all of these details, as you see, is here. The internet protocol, and so on. Okay. Now this is what if I now the length is greater than 5, for example, 500, 500, yes, like this, 50, 500. If I want to equal 50, no, 63, nothing, 68, and so on. Sorry, 68, and so on. I have one here. Okay. Now with this practice, okay, download this practice one, the pickup that I've already attached it. Okay, and find the IP address of my computer, find the IP addresses that being used, find the port numbers and the services that being used. This depends on the specific port number. You can pause the video, or we will continue. Okay, we will continue. Open the bcap. As you see, this is all the thing we have. Now, how to find my IP address of this computer that being used to capture the packet? Now, we will use this lead. Now, TCP has three-way handshaking, as we mentioned before. Now, SYN, ACK, ACK. So, let's start with this lead. So, tcp.flags.syn equal 1. Okay. Now, of course, now the client, which is our computer, will try to connect to the using the browser to the server or to specific website. Okay, we will find it from here. Now, of course, my computer will have SYN and ACK, so I will do the search right now. So this is SYN. Okay, or tcp.flags.ack equal 1. Okay. Now anything, either SYN or ACK will be displayed. Okay, as you see, 1,999 packets displayed only like this, like almost 94%. Okay, now this is SYN. This is SYN. No, SYN. Yeah, I know it is IP address, but we don't sure. We didn't sure if this is our IP address or not. But we have to find the packet that sends SYN ACK with the specific TCP flags or sequence number and acknowledgement. Now let's see this. The number 16 here. As you see, this is SYN and this is SYN ACK. How to make sure this is or these two packets are connected? It doesn't mean that if they are behind each other that this is related to this. No. how to know that? By the sequence number. Look at this. This is TCP. The protocol is used is TCP, and this is as you see, the port number is from this arbitrary port number to the 443, which is HTTPS, secure socket layer. The sequence here is 0. So the SYN-ACK, the acknowledgement must be 1. As you see, the acknowledgement is 1, which means that this is connected to this. Okay? So if this is SYN and this is SYN-ACK, so, and this is the ACK, as you see, the sequence is 1, acknowledgement is 1. Acknowledgement 1, or the sequence is 1 for what? For this sequence, which is 0. And the acknowledgement here is 1 for the sequence 0. Okay? And the sequence is 1 because it is something new. Now, this IP address is my IP address. 192.168.101 IP address. Okay. Now this is. Now what is the service, or what is the port number? Of course, as you see, 443, which is HTTPS secure socket layer. Now this is another one here. As you see, SYN. The sequence is 0. The sequence is 0, but this has no meaning at all because no acknowledgement until now has been reached. Yes. If you want just to make sure it is this, how to know that? As we learned before, TCP.port, or if you want .port, yeah, equal 55491, which is this one, as you see. If I want to find if it has ACK or SYN-ACK and so on. As you see, yeah, it has. This is SYN, this is SYN-ACK, this is ACK. Yeah, it has three-way handshaking, which we will use this lead to find our IP address, or the IP address of this machine, which is, yeah, the same IP address that has been extracted. Okay, so good, so far so good. Now, how to find all the IP addresses that been captured during this file, or this bcap file. As you see, this is statistics in the toolbar, file, edit, and so on. This is statistics. Press it. You will find this IP version 4 statistics in the bottom, as you see here. Now, you will find specific options or specific tools like all address, destination and ports, IP protocol type, source and destination addresses. Click all addresses. You will find, as you see here, all the IP addresses that been captured or resulted in this file. As you see, this is the DNS server, of course, because 1101 and so on. DNS server, this is another IP address, I don't know why. This is our IP address, this is IP address, I don't know, it is for something. This IP address is for a website or maybe services. This is for broadcasting, I think, and this broadcasting, multicasting, and so on. And you see these maybe for a website, or we don't know for sure, or services like or DNSs or anything. Okay, now this to find all the IP addresses. Again, click statistics, click here. Now how to find the port numbers? Not all addresses. Click here, destinations and ports. Click it. Now you will see that all thing is here. As you see, TCP or UDP. Now this IP address has UDP with this port. This is UDP, this is TCP. As you see, this IP address has TCP, which is 443. 443 means that this is HTTPS, secure socket layer. Now this is 80. Okay, this is 443 and so on. Now how to know what these websites? Of course, open your browser, type the IP address. For example, I will put this, or you can put anyone. It may give you result or not. For sometimes the DNS block the IP address like this. Must be domain sometimes. Okay, this is UDP, as you see, with these port numbers, TCP. So to make sure, if, as you see, nothing, give us nothing, cannot be reached. Okay, no problem. Now, okay, now from the result, as you see, we will check for the port numbers. So there's specific trojans or malicious softwares that use specific port numbers, and it is listed online. You can find the list. So find any port number that being used in those Trojan list, and you will find if there is a malicious software on your computer installed, or backdoor, or any bad program, virus, anything. Okay, how to find that? During or using the port number. Okay, because every program has a specific port number. Okay. Now, thank you. Practice 2. Now in this practice, we will find out if this program is malicious or not. Okay, now you have two files, .bat or .sh. Now .bat for Windows users and .sh for Linux users. Okay, download it. Okay, now before you download these files, why I put it like this, .bat or .sh. Now before that, .bat and .sh is files that has commands in it, series of commands, and can be run sequentially or parallel. It doesn't matter how you put these commands inside this file. Okay, now why I put it like this, .bat. Now if you right click on one of them, you will see what's inside the program. So this is not a program, in fact. This is just a sequence or series of commands we put inside it. So why I put it this? For transparency between us. So you will know that you haven't downloaded any malicious or spy software or programs into your computers. So don't worry and keep calm. So after you download it, open one of these. Now before we start, open the Wireshark on the interface. Now I am running the Wireshark. I see this is up, nothing. Now if I run it, I bet because it is a user. As you see, I have ICMP packets. Wait a minute, this is not a good. As you see from my computer, as you see, this is the IP address of mine. IP config. Yes, 8.1.101. As you see, where it is, yes, 8.1.1, and this is the IP address of a specific website. Let's see what is this IP address. Yeah, forget that. .58. Sorry. Yes, 196. Again, not 196. It is 286. Yes, it is google.com. So I am trying, this program is trying to ping google.com, and this is something not good. So this is malicious. So of course, if you right click the edit, ping google.com CLS, the result will be CLS. So if I run it, a black screen will appear. Okay. Now the thing here, of course, this is not a concern for google.com or any website right now. Why? Because this is a simple ping. We will send, as you see, 3 or 4 packets, ICMP packets, to Google, and it will be discarded, no problem. But we have to think like hackers, or how hackers or criminals thought or things. We have to think like them. Okay, so we shouldn't underestimate anything we see. So this thing can be modified. So I can increase the ICMP packet that we send, or I can send this program to various, to thousands or hundreds of thousands or million computers worldwide. So this would be a concern. Okay, so we knew that this is a malicious software. Now let's start with practice 3. Now in this practice, we will handle the HTTP traffic. Okay. Now before we start, Now, why to use HTTPS instead of HTTP? Okay, the reason will be explained in this practice in a practical way. Okay, not just as a theory. So, the first thing, open your Google, type test login HTTP, open any login test like this. For example, testing ground scrapping pro login. As you see, this is website that aimed just to, as you see here, enter admin and 1 2 3 4 5 here, and while you are entering, make sure you are running the Wireshark. Just I want you to see this. Okay, now I am capturing right now. Forget that. Now type admin 1 2 3 4 5. Now as you see, there is no secure socket layer. Connection is not secure, as you see here. So if I type login here, it is very dangerous. I put sensitive information, which is admin, username and password. Now if you can stop it. Okay. Now if I find here, you can see all the traffic has been captured. Okay. So if you look at this HTTP, for example, or type HTTP here, as you see, you will see the post method with its value. This is a post method, as you see here, post method. But because it is not HTTPS and not secure, so all the credential is available. As you see, the user, which is the item, the name of tag in HTML is, his name is user, and password is admin and 1 2 3 4 5. So the password and the username is revealed. This is so dangerous. Okay. Again, how to find this? Another thing, TCP contains, why TCP? Because it is HTTP, hypertext text transfer protocol, use TCP protocol. So TCP contains login. For example, as you see, if I put here this, the hypertext transfer protocol, all the data is accepted. As you see, the language here, encoding, referral, I'm coming from this, content type, all this is available. Now the most important thing here, as you see, is the username is admin and the password is 1 2 3 4 5. So this is very dangerous. So make sure you use HTTPS, which is secure socket layer, okay, instead of HTTP when you are trying to log in, even though when you are trying to surf the internet or browsing the websites on the internet, make sure you are running using HTTP. Now if I put for example test and I put 111.111, okay, or anything, make sure you are capturing right now, remove that, login, okay, access denied, of course, but as you see here, HTTP, for example, HTTP, as you see here, the user is test, the password is 111.111. So all the packet has been captured. Yeah, all the packets have been captured and sniffed, and because it is not using HTTPS, which is secure socket layer that encrypt the traffic, actually we see it as explained. Okay, we see it as explained. As you see, this is the response. This is the response 200. Okay, this is the code that it is accepted. As you see here, we can find all the information we want. So you have been deleted, or they know what your password is and username. This is very dangerous. Okay, now if you have any question, just let me know. Thank you. Also, you can try these on another websites like this, or any websites, or even though in a local website, it doesn't matter, but the mechanism is always the same. Don't use HTTP, just use HTTPS. Thank you.